Hi, hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students, and subscribers for their continuous support and encouragement. Today's topic of interest is model laws. The model laws in fluid mechanics plays a vital role and it describes a relationship between the model as well as the prototype. First of all, we have to know what is meant by a model and what is meant by a prototype and why it should be needed. Let us consider this is a dam. We have to test the dam, their strength and how much it can be stored and how the flow is being taken care. So for this testing purpose, we cannot do a prototype because a prototype is an actual replica of a component is called a prototype, whereas a model is a small scale replica of the prototype is a model. So here you are seeing the image of a model. So we are making a smaller scale having a capacity ratio, and we are going to have a some amount of similarities between the actual model, actual component, actual structure as well as the model. So these similarities and similitudes are being taken care by the model laws. With the laws only, we have to manipulate and we have to calculate the values for the actual scale. So, for your better understanding, you can see a prototype. This is a prototype, and this is a model. A small scale actual replica of a component is a prototype, whereas a small scale is a model. If we do a small scale in order to make our calculations better as well as we to reducing the time, reduce the cost involved in this testing process, we are using these models as for the analysis. So, with this background, I'm going to continue the model laws involved in fluid mechanics. Here, we are going to concentrate on two model laws. One is Reynolds Model Law, and another one is Froude Model Law. Here, the Reynolds Model Law states for the viscous and turbulent flow over a closed pipe or a conduit. Mostly, it is used for the pipe sections. So, pipe sections carrying a fluid, we can convert into a model laws. Here, we are using a Reynolds number to compare the model as well as the prototype. We know that the Reynolds number RE is equal to rho VL by mu. Here rho is the density, V is the velocity, L is the characteristic length, and mu is the viscosity. So we are going to compare Reynolds number of the model to the Reynolds number of the prototype. Here the scale ratio SR is the value of model and value of prototype. So this is the scale ratio. So here if we want to know the scale ratio of the density, we have to do the scale ratio of density ratio of model to the density ratio of prototype. Then we get the scale ratio, density scale ratio, like that. All the scale ratios in the equation which is equal to 1. So this is the output of the Reynolds Model Law, where the Froude Model Law, it is for the open channel flow. The application is for open channel flow. If we want to test, or if we want to conduct an analysis of a dam, of a channel, of a spillway, we can use the Froude Model Law to compare the model as well as the prototype. We know that uh, Froude law is the ratio of inertia force to the gravity force. So inertial frame to the gravity frame is the Froude model law. Here the Froude number is equal to V divided by root of G into L. Here V is the velocity, G is the gravity, and L is the characteristic length. Here we are going to calculate, we are going to compare the Froude number of model is equal to Froude number of the prototype, and we know that the scale ratio of the Froude number is equal to 1. Therefore, for the scale ratio, the characteristic length, the scale ratio for the different kinds of the things we have given, I would like to explain this here. If the LR is, we want to find for the area, it is A0, that is equal to 1. Where if we want to find for the time, that is root T, or if we want to find for the velocity, it is root V. If it is a pressure, it is P, and it is for discharge Q power 2.5, and it is for force, the LR ratio is F power 3, and for power 3.5, power 3.5. If for torque, it is T power 4. If it is mu or viscosity, it is 1.5. So like that, the power ratios can be varied. Here, as per the Froude number, we categorize the open channel flow into three types. If the Froude number is less than 1, it is called subcritical or tranquil flow. If Froude number is equal to 1, that is called as a critical flow. If the Froude number is greater than 1, it is called supercritical or shooting or rapid flow. Okay, and after we know these two model laws, we have to know the similarities between, we have to keep these similarities between the model as well as the prototype. Here the three similarities are very important. One is geometric similarity. The geometric similarity is defined the similarities between the model and prototype in terms of length, breadth, and height. That is why the shape similarity is called geometric similarity, whereas kinematic similarity is the motion similarities like velocity, acceleration, discharge, stream, and viscosities. All those things are come in terms of kinematic similarities. The kinematic, what is meant by kinematics? uh, Body in motion without considering force. The parameters involved in body in motion all are put together, and comparatively it is called as a kinematic similarity. And dynamic similarity is the motion involving the force. Therefore, the similarities between the force, power, torque, pressure are being accounted or being compared. So that is why it is called a dynamic similarity. So here with this I am closing the today's session. The fluid mechanics model law is very important, and it is very interesting for finding the relation between the model as well as the prototype. So it is very important for the big component construction like a ship flowing in a sea, a ship flowing in a river, or an aeroplane is flying in an air, or if we want to design an dam, if we want to design a turbine, these model laws are very very important and giving very much accurate value in terms of all the similarities. So with this, I'm closing today's session. If you have any doubts, please let me know in the comment section. I will put on another video for clarifying your doubts. So until, thank you and bye bye from Santhosh. Thank you.